Hey there, yes, it's you. Welcome back to Code Conyo. For today, I am going to uh, continue discussing about the idea of recursion or recursive method or functions in Java. But at this juncture, we are going to focus on the time complexity, which we are going to compute or calculate the time complexity of these two algorithms that we created. So specifically, we have here first algorithm or algo. We have here a method that implements an iteration or iterative approach, while the other one is a recursive approach. Okay, so um, we when we are going to compute manually the time complexity for this algorithm using the T of n. So since this is a declaration, this is like one, okay, or this is like computed as one, and then this one right here is also another declaration. So this is one, and since this one I less than or equal to n. This is supposed to be like this is like n plus 1. And since that is a condition, while this one is equal to n, since this is a calculation or a process, and we'll also be going to have here an n. And that's also include returning statement like as 1. Okay. Now, we come up with the t or time complexity or function of n is equal to, so we have one, two, three. Okay, so this is like one, two, three. Okay, so this is a 3n plus then one, two, three, four. So 3n plus 4. So if the value of our n is let's say 5, and then therefore the our n would have um, would have five n. The value of n is 5, so n will have 5 as it is being substituted by that value. So 5 times 3, 15. So we have 19 units of time. Okay, so if the value of our n is 10, so we have um, 34 units. So as our n increases, the time required for this algorithm is also going to increase. Now, how about this one? So we're going to have this one. So this is since this is a condition, so we would have here n plus 1. And since this is also another condition or a process rather, so this is n, and then we'll have here 1. So basically we have t of n, sorry, so is equal to, so we have 1, 2, so we have 2n, sorry, 2n plus 1. So if our n is like 10, so therefore we have only 21 units of time. Okay, so by looking at it, of course, we can say that this one has a lesser complexity than that of the first one, or the sum of natural numbers using or using the implementation of loop. Now let's prove it by uh, in by using a or implementing a by calculating the system time using nano time. So let's have here start time. So let's prove it in our program if we are actually correct. So let's use nano time. Okay, this is the start time, and we are also going to have here the end time to compute the time required upon the execution of this algorithm. So we'll have here system.out.print line, then we have here time required or execution time up here, end time, sorry, end time, what happened to my keyboard? So uh, it should be parang I should need to replace this one. Okay, so let's also have another version for, okay, in our next uh, method, which is recursion. So let's run it together and let's see if how much time required for this algorithm and how much time required upon the for this algorithm. So let's run and okay, there you are. Wait, end time minus start time. We all wait, okay. So what happened? Units. Oops. Okay, so let's run again. So we have here as you can see in the execution time, we have 2,284 units required for the first method or algorithm, which is we implemented here a loop. And while in the second method, which is a recursive method, is only going to require us or an execution time of 638 units. And as you can see, there's a really big difference between the two. Okay, so both manually and using the system, using the system time in Java, it's um, it's it's glaring that it's it's this method or this recursive method is really faster or efficient compared to the first algorithm which implemented for loop approach. Okay, so I guess we call it a day. Thank you guys for watching this video and have a great day ahead. Bye bye.